The 10th question that we have is a very important question from IT JEE point of view because it teaches you how to interpret graphs. We have a transverse wave traveling in the positive x direction. We need to find out which points have upward velocity, downward velocity, zero velocity and maximum magnitude of velocity. So for solving that, you can write equation and solve, but that would be very tedious. So the best way is that you shift this waveform towards right. This was the graph for a particular time instant, say t is equal to 1 second. Just for t is equal to 1.001 seconds, suppose, the graph will be like this. This is the dotted line. So just by drawing this graph, we can analyze which points have upward velocity. So in the just next time instant, point A has gone downwards over here. Therefore, this must have had negative velocity, that is the velocity in the downward direction. Similarly for point B, since it has come downward in the just next instant, therefore it must be having a velocity in the downward direction. Same goes for point C, but the point C is at its extreme position, therefore it has a velocity of 0. Now the points with upward velocity are the points D, which has moved upwards, point E, which has again moved upward, point F, which has also moved upward, and point G, which has moved upward, but at this instant it had a velocity of 0 since it was at its extreme position. Therefore the points which have upward velocity are D, E and F. We neglected G because though it has moved upwards in the just next instant, but its velocity was 0 at this extreme position. So now we need to find out which points have downward velocity. So clearly A had downward velocity, B had downward velocity, C had 0 velocity, though it has come downward, but we neglect C. Why? Because it had 0 velocity at its extreme position. So our answers are A, B, even H has moved downwards, A, B and H. Now we need to find out points having 0 velocity. Points having 0 velocity are clearly the points at their extreme positions, that are C and G. The points having maximum magnitude of velocity are definitely the points which are at their equilibrium position, that is A and E. You should remember this, that the points at the extreme position have 0 velocity and the points at the equilibrium position have maximum velocity. This is because you can see it by the equation also, y is equal to A sin omega t minus kx plus theta. Del y by del t, that is the velocity of a particle at a particular time, is equal to A omega cos of omega t minus kx plus theta. Whenever this term is equal to 0, suppose 0 or multiple of pi, then the sine term becomes equal to 0, that is the displacement is 0. But when this same term is 0, this cos 0 becomes 1 and the velocity of the particle is maximum. That means whenever the displacement is 0, that is at these points, the velocity of the particle is maximum. The magnitude of the velocity of the particle is maximum rather. And similarly, whenever the particle is at its maximum displacement, then the velocity is minimum, that is equal to 0. So we get the final answer for our 4 options as A, B, H, C, G. A, B, H points have downward velocity, C, G have 0 velocity, D, E, F have upward velocity and A, E have maximum magnitude of velocity. We could solve this question very easily just by interpreting the graph.